Good morning. Welcome to Mission Control Houston. This is the International Space Station Flight Control Room, where the Orbit 2 team of flight controllers is on duty now, keeping an eye on the operation of the station's systems and working with the Expedition 56 crew members in the last few hours of their work week on orbit. The agenda for this week included a lot of science work inside the station's several laboratory modules, and almost 8 hours of work around the outside of the Russian surfaces of the Russian segment of the station.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Gary Jordan. Sometimes to really understand animal behavior, you have to think a little bigger, or in this case, a little higher. Russian cosmonauts Oleg Artemyev and Sergei Prokopyev installed an experiment called Icarus during a spacewalk this week. Icarus is a collaborative project between Roscosmos and the German Aerospace Center DLR to study the migratory patterns of small animals tagged on Earth with GPS hardware. The experiment may provide data about how animals move locations, how population density shifts over time, and how diseases spread. The cosmonauts also deployed 4 small technology satellites and retrieved materials science samples during the spacewalk. Liquid behaves strangely in microgravity. It forms these balls and seems to stick to whatever surface it touches. But how easy can you control it? An experiment conducted this week looks at just that. The Surface Tension Containment Experiment 2 takes the science out of the glove box and within the open cabin of the space station. The experiment looks at the formation and capture of microdroplets using airflow when a pipette interacts with the liquid to see just how stable it is and how well it can be controlled. Assessing these techniques can allow more science to be conducted outside of a glove box, meaning more science overall. Ricky Arnold connected with students at the Microsoft Youth Spark event that took place early this week at Space Center Houston, the official visitor center of NASA's Johnson Space Center.
What was the most surprising aspect of executing a spacewalk?
I think the most surprising aspect for most people is how long the day is. We are only out doing a spacewalk for 6.5 hours, but that's 6.5 hours where you only have water to drink, there's no food, and you're basically the equivalent of jogging pretty hard in terms of how hard you're working for that time frame. But we're actually in the suit closer to 10.5 hours.
Youth Spark is an immersive day-long conference designed to empower young people to improve their communities and the world through the pursuit of careers in science, technology, engineering, arts, and mathematics. Keep sending in your questions using the hashtag #SpaceToGround. And for those teachers getting ready for the school year, check out the Space Station Research Explorer for some fun student experiments, including growing non-organic materials in a garden just like plants. We'll see you next week.
Ricky Arnold's interaction with students in Houston this week is the kind of engagement that's common for station crews during this year of education on station. NASA has activities planned to help students and their teachers get the most out of learning about science, technology, engineering, and math. And that includes a series of demonstration videos. In this one, astronaut Joe Acaba talks about exercise on orbit.
Welcome to the International Space Station. I'm astronaut Joe Acaba. Today, we're going to talk about potential and kinetic energy. Let's get started. Kinetic energy is the energy an object has because of its motion. An object can store energy based on its position. This is called potential energy. On Earth, imagine dropping an object from a raised position. As an object's altitude above the Earth's surface increases, its gravitational potential energy also increases. The potential energy stored due to its position is now being converted to kinetic energy. We also observe this with elastic potential energy.
Okay, new term. Elastic potential energy occurs when objects are compressed and stretched, or generally deformed in any manner, creating potential energy. Think of this bungee or a spring. Okay, Joe, what's next?
We pull back on the band and create potential energy. When we release the potential energy, it is converted to kinetic energy. Here on the International Space Station, we are still under the influence of gravity, primarily due to our position with the Earth. So when I have this ball on this ramp, normally back on Earth, I release the ball and it rolls down the ramp due to a change in its potential energy that's being transferred to kinetic energy. But as you can see, it doesn't happen here. So it doesn't mean we don't have potential energy. It just means we're not converting it at this time to kinetic energy. And why is that? Gravity is pulling us down, but we're moving super fast. And so what it is we're bending around the Earth in this perpetual falling motion. Thanks for joining me on board the International Space Station. We're sending it back to Earth so you can try your own experiment. See you next time.
The International Space Station serves as a one-of-a-kind platform for scientific research, taking advantage of the microgravity conditions to perform experiments that can't be done on Earth. That includes experiments inside a new atomic refrigerator that's capable of cooling matter down to just above the point where, in theory, the thermal activity of the atoms comes to a stop.
Cool Science on the International Space Station. Presented by Science at NASA. NASA researchers are creating a spot colder than the vacuum of space inside the International Space Station. It's called the Cold Atom Lab, or CAL, and it can refrigerate matter to 1/10 billionth of a degree above absolute zero, just above the point where all the thermal activity of atoms theoretically stops. At this temperature, atoms lose their energy and start to move very slowly, explains Rob Thompson, CAL project scientist at NASA's Jet Propulsion Laboratory, or JPL. At room temperature, atoms bounce off each other in all directions at a few hundred meters per second. But in CAL, they'll slow down a millionfold and condense into unique states of quantum matter. CAL is a multi-user facility that supports many investigators studying a broad range of topics. Eric Cornell, a physicist at the University of Colorado and the National Institute of Standards and Technology, will be leading one of the first CAL experiments. Cornell and his team will use CAL to investigate particle collisions and how particles interact with one another. Ultra-cold gases produced by the Cold Atom Lab can contain molecules with 3 atoms each, but which are 1,000 times bigger than a typical molecule. This results in a low-density, fluffy molecule that quickly falls apart unless it is kept extremely cold. How is particle behavior affected as more particles are introduced? What can be learned about quantum objects when several atoms are interacting at the same time? Cornell says the way atoms behave in this state gets very complex, surprising, and counterintuitive, and that's why we're doing this. Cornell shared the 2001 Nobel Prize in Physics for creating Bose-Einstein condensates, another state of quantum matter that can be studied inside CAL. Bose-Einstein condensates are essentially blobs of quantum matter that look and behave like waves that exist at these ultra-cold temperatures. In the free fall of space, the condensates can hold their wave-like forms for 5 to 10 seconds, much longer than on Earth, providing researchers a window into the quantum realm. Thompson says we can use CAL to test general relativity and quantum mechanics. One of the biggest questions in physics today is how those two work together. University of Rochester physicist Nick Bigelow and University of Berkeley scientist Holger Mueller, along with their colleagues, plan to use CAL to test a cornerstone of Einstein's theory of relativity, the equivalence principle, which holds that gravity and external acceleration cannot be distinguished experimentally. They plan to repeat Galileo's iconic experiment dropping cannonballs off the Leaning Tower of Pisa, but using atoms instead. Dropping atoms inside CAL and letting them fall for several seconds as the station orbits Earth will allow researchers to precisely figure out the differences between how the atoms accelerate. This experiment may reveal how gravity and spacetime are woven through the quantum realm. A researcher at JPL named Jason Williams also plans to use ultra-cold two-atom molecules to develop tools for the next generation of precision gravity tests with quantum gases. Many more experiments are planned for this cool new laboratory, and no one knows where they will lead. With Cal, says Thompson, we're entering the unknown. For more from the International Space Station, visit www.nasa.gov/station. For cutting-edge physics on and around Earth, stay tuned to science.nasa.gov.
A tool that has been used for centuries to help guide sailors across the ocean is being tested on the International Space Station. It's an experiment looking into the use of a handheld sextant as a potential emergency navigation tool to guide spacecraft across the cosmos.
orbit, they can use their sextant. An astronaut lines up a known star and a prominent landmark, and feeding his readings into the computer, gets his position back from the machine.
Jared's pointing right now at the sextant and a telescope, which are our navigation means to get home.
Being able to identify microbes aboard the International Space Station in real time would be revolutionary for the world of microbiology and space exploration, and the Genes in Space 3 team that turned that possibility into a reality when it completed the first ever sample-to-sequence process entirely on orbit last year. This advance could aid in the ability to diagnose and treat astronaut ailments in real time. It could benefit other experiments on the station and maybe assist in the identification of DNA-based life on other planets.
So then we kind of went for the home run experiment, which is actually trying to get a sample that originated on the ISS.
And the goal was really to show that you could go all the way from a sample to an answer all on board.
I am going to do this really neat experiment today. Last week we took some surface samples, microbial surface samples. There'll be enough DNA after we magnify it to sequence it, and then from that sequence then we can determine what type of bacteria it is. So it's going to be really exciting for us, I think, to try and do this for the first time all on board the space station.
In that moment, she's in the microgravity science glove box as she's collecting those cells. My heart was just pounding because what she did had never been done.
Our DNA cake is in the PCR oven. We'll look forward to getting lots and lots of DNA from each of those 3 little bacteria colonies.
They're like, we can just patch your cell phone in to the space to ground loops, and you can just talk to Peggy on your cell phone to do this. There's a hurricane raging literally outside, but the folks in Marshall, they're on it. They're gonna make this happen. Science on station is not stopping because of Hurricane Harvey. And right away, we saw one microorganism pop up, and then a second one. I thought, oh my gosh, I am watching the first sequences ever of an unknown from space.
I checked several times. Like, I ran like a biochemical test, and then I ran 2 different sequencing tests. We are 100% sure that our samples that we got back on the ground are exactly the same that we got on orbit. We did it. Everything worked perfectly.
As a microbiologist, my goal is really so that when we go and we move beyond ISS and we're headed towards Mars or the moon or wherever we're headed to, we have a process that the crew can have that great understanding of the environment based on molecular technology.
Orbital debris poses a risk to all spacecraft in Earth orbit, and the International Space Station has a new debris impact sensor to provide information on the environment of low Earth orbit. By monitoring impacts caused by small-scale floating debris, the space debris sensor will generate a better estimate of the total amount of stuff out there, and that could help better define shielding requirements for future spacecraft. The space debris sensor was delivered to the space station on a commercial cargo ship. The Dragon and Cygnus ships from SpaceX and Northrop Grumman were produced as a result of a NASA program that was designed to help private companies get involved in space flight and space research. Alpha Space, the company responsible for developing the Missy flight facility, is another example of the results that program has produced.
Alpha Space was formed in 2015 and really is a product of this new commercialization in low Earth orbit. It was formed specifically to create a commercial payload that would be available in space for private industry. The Missy dates to the early 2000s, was the first mission. It's been utilized by NASA, by the Department of Defense for different experiments. And then around 2010, NASA put out a call for ideas to privatize portions of the space station. And so we responded with a proposal to that, and that's how we ended up with our cooperative agreement. For material scientists who want to test their materials or components in a harsh environment, the Missy platform really offers the most harsh environment that's available, and that's external to the space station. Previous Missies were one-time use, sort of suitcase style. They would open up and expose these materials to space. The Missy platform is a permanent platform that's all robotically serviceable, commandable from the ground from our operations center here. We don't only test materials, we can also do technical demos, we can test circuitry, computer boards, cameras, and its serviceability and changeability allows science to continuously happen for 10 years going forward. Every day, new commercial companies are coming into the fold of this new economy that's developing. I think the space station is a great platform to start commercialization, and I think platforms like the Missy are going to drive a new demand in space.
Robotic technology that was originally designed for the International Space Station has found a new application in healthcare as part of a telerobotic technology to provide MRI-guided breast biopsies to women who are in remote areas. The Canadian Space Agency contributed to the production of this feature about the innovations coming from the Centre for Surgical Invention and Innovation in Hamilton, Ontario.
Space represents a fairly harsh environment. Any piece of equipment that's exposed to it over a long period of time would require maintenance.
So every time we have to do a maintenance on the outside of the space station, that means a crew member has to suit up and go outside. That introduces that crew member to risk and puts that person in harm's way. The other issue is that now they're spending the time doing the maintenance work and they're not doing the science, which is really what their purpose is. So with the maintenance challenges that we were going to have with the International Space Station, what we found ourselves was Canada being in the position to provide a solution to that problem, and Dexter was going to be that solution.
Dexter is a two-armed robotic manipulator system capable of performing fine motion tasks to replace what an astronaut would need to do on the exterior part of the space station.
Dexter is essentially a handyman. It operates on the outside of the International Space Station. It allows us to do maintenance operations. One of the advantages with Dexter is that we're able to control it from the ground.
And so the ground crew could actually operate these robotic systems and free the astronaut up from that task as well.
So now that Dexter's online on the space station and operating on a regular basis, what we've got is we've got a crew who's spending more time doing science. And this is important because this was really the whole idea of building the International Space Station, was to be able to do science in low Earth orbit.
Unfortunately, only about 40% of women should be getting annual MRI as part of their screening undergo MR screening. Part of the reason why women were not undertaking MRI screening was because of lack of access to the best radiologists locally.
Some women have to drive very long distance, like 7 or 8 hours of car in snowstorm during the winter, sometimes risking their lives just to get their MR-guided breast biopsies.
When we started to do the research with Canadian Space Agency and NASA on the whole remote telesurgery, we started to get involved with MDA. MDA is a Canadian company which has been involved in manufacture of all the robotic systems which is currently used on the space station.
So we developed a system called IGAR, which stands for Image Guided Automated Robot.
IGAR is a tele-operated robot that performs breast biopsies under MRI guidance.
One of the capabilities of IGAR is to be controlled by radiologists from any distance. And that allows basic A radiologists to supervise MR breast biopsy on a patient who may be hundreds of kilometers or thousands of kilometers away from them. It means that the patient can undergo their breast biopsy in their own local hospital without having the need to travel to another city or another hospital to get access to the expertise.
And the results are very, very encouraging. So we've demonstrated that the IGAR is safe, extremely accurate as a human.
And this will allow us to hopefully increase the number of people undergoing screening close to 100% where it should be. So IGAR is built on many of the know-how which was developed for the space program, as well as the software which is also used to control the robotics on the space station.
We can actually see some of these technologies we worked with for a long time becoming available. You know, we have a lot of insight on how to apply them, not just in medicine, but in a number of other fields, which is what we're doing. So without the space station, would any of that have happened? No, not really. No, not in that way, anyway.
For nearly 2 decades, the International Space Station has hosted astronauts from around the globe working on groundbreaking science to push the boundaries in a variety of fields. But NASA astronaut Randy Bresnik tried to capture the beauty of this immense spacecraft in a series of photos that he took during his long-duration mission last year. This is his argument for the International Space Station as art. If you'd like to get another look at any of the stories we feature today, and who wouldn't, check us out on YouTube and on Facebook. There are the addresses popping up on the screen. While you're there, be sure to look around, and a lot of other cool stuff you'll find there about NASA and America's human spaceflight program. You should also check out Houston, We Have a Podcast, featuring folks here at NASA talking about their work in all aspects of space exploration. The new episodes post on Fridays. Today, August 17th, the second part of our series on the hazards of human spaceflight. My colleague Gary Jordan talks with human factors and behavioral health scientist Tom Williams about the pitfalls endured by astronauts on very long space flights because of their isolation from most of human society. Go to www.nasa.gov/Johnson/HWHAP. Houston, We Have a Podcast. You'll find all the episodes there. You can also listen to all the episodes on iTunes, Google Play, and SoundCloud. This is Mission Control, Houston.